Okay, so let's jump right in. We're looking at a problem that I think a lot of systems integrators know all too well.
The long-haul cable run nightmare.
Exactly. You're trying to get a high-quality video signal from a computer to a screen, but they're maybe, what, hundreds of feet apart, maybe even a mile.
And with standard copper cables, you're just not going to get there. After 15, maybe 20 feet, the signal just starts to fall apart.
You get that snow on the screen, the ghosting, or just nothing.
Right, a black screen.
Which is where the piece of hardware we're digging into today comes in. It's the NTI FIBER-D-LCLC-50-300M.
It's a DVI extender. Basically, it's a set of small boxes that lets you use fiber optic cable instead of copper for your video.
And the distances they're claiming here are pretty wild. The spec sheet says this thing can push a video signal nearly 5,000 feet.
4,920 feet, to be exact. But, and this is the important part, that max distance really depends on the type of fiber you use.
Ah, right. I saw that in the data. It distinguishes between single mode and multimode.
And the difference is huge. Multimode fiber will get you about 1,640 feet.
Which is still really impressive, but it's not that nearly a mile figure.
Yeah.
So single mode is what gets you the full range. Why such a massive gap?
Well, it really comes down to how the light travels through the cable's core. Think of multimode fiber as a wide hallway.
Right.
The light signal sort of bounces off the walls as it travels down. That's fine for a short sprint, but over long distances, those bounces cause the signal to spread out, to disperse.
And single mode?
Single mode is like a super tight tunnel. The light just shoots straight down the center with almost no reflection.
So less bouncing means less signal loss.
Exactly. That direct path maintains the signal's integrity much, much further.
And you need that integrity, right? Because we're not talking about sending a basic low-res feed here. The specs list support for resolutions all the way up to 1920 by 1200.
WUXGA. Yeah, and that specific resolution is worth pointing out. It's a 16:10 aspect ratio, which is still the standard for a lot of high-end medical imaging displays and like industrial control panels.
So we're talking about displaying critical data where every single pixel counts.
Precisely. This isn't just for playing a 1080p movie.
But, distance isn't the only enemy here. When you run a cable a mile through a heavy industrial plant, you're passing all sorts of stuff.
Massive generators, motors, high-voltage lines, and this is where fiber really shines over copper.
Because that mile-long copper cable is basically just a giant antenna, isn't it?
It is. It just sucks up all that electromagnetic interference, EMI, and radio frequency interference, RFI. All that noise just destroys the picture.
But because fiber transmits data using pulses of light,
it's completely immune to all that electrical noise.
Which is why the source material highlights applications like medical monitoring and industrial traffic control.
Right. You can run these little fiber cables right next to an MRI machine or a factory turbine, and that signal will stay absolutely pristine. It's all about reliability in hostile environments.
Speaking of the environment, the form factor on these units is surprisingly small, like 1.5 by 2.5 inches.
Yeah, they're tiny. You could easily just tuck one behind a flight information screen at an airport or inside a kiosk.
There's also a feature listed here called ED learning that caught my eye.
Ooh, that can be a major pain point. ED is the data that lets the monitor talk to the computer, the handshake that says, hey, I'm a screen and here are the resolutions I can handle.
And if that handshake fails, the computer won't output any video.
Exactly. So this device clones the monitor's ED'd info, it memorizes it, so the computer always thinks it's plugged directly into a screen that it recognizes.
So it happens instantly, even with a mile of glass in between.
That's the idea. It just works.
So you've got a setup that fools the computer into thinking the screen is right there when it's actually on the other side of a stadium.
That's the perfect real-world application. Imagine those massive LED scoreboards. The computer driving them isn't sitting out in the heat.
No, it's tucked away in a climate-controlled server room, safe and secure.
And this extender is that invisible infrastructure bridging the gap. It effectively decouples the user interface from the processing hardware.
It's a solid reminder of just how much engineering goes into simply getting an image from point A to point B.
It really is.
So here's a thought to leave you with. Next time you're looking at a digital schedule in a train station or a monitor in a hospital, just ask yourself, where is the brain? How far away is the actual computer driving that image?
The answer might be a lot further than you think.
Thanks for joining us on this deep dive.